We are given m cross n grid where each cell can have one of three values, either 0, which means an empty cell and there is no orange in that cell, or we can have 1 as a value, which means we have a fresh orange in that cell, or we can have 2 as a value, which means we have a rotten orange in that cell. And every minute, any of the fresh orange that is surrounded by a rotten orange also becomes rotten. So what we have to do is return the minimum number of minutes that must elapse until no cell has a fresh orange, and if it's not possible we will just return -1. We can solve this question by creating a queue of all the rotten orange. The coordinate we will store in the queue, we will store it all the rotten orange coordinates as a tuple, and for each of these rotten orange we will using for loop check the adjacent cells and see how many orange can it fresh orange can it rotten, and we will keep on doing it until the queue is empty, there is no rotten orange in the queue, and then later we will check if there are any fresh orange left. Let's initialize number of fresh orange to 0, and also we will initialize a queue rotten orange queue, we can name it like this and initialize it, and we will use the for loop to traverse through this grid and find the number of fresh orange and also add all the rotten orange coordinates to this rotten queue. So for I in range len grid, and for j in range len grid 0. What we will do is we will check if grid I j is equal to 1, means it's a fresh orange, and then we can append it to fresh orange. And in the other condition, if it is a rotten orange, we will check if elif grid I j is equal to 2, we will just append it to rotten orange queue. And as I said, we will append the coordinates because we want to traverse in the left, right, up and bottom direction to make all the fresh orange rotten every minute. So we will have I comma j, and we will also in this tuple we will save the number of minutes elapsed since starting. Initially it will be 0 for all the rotten orange. Now we will have the number of fresh orange and rotten queue as well, and as you will notice we did not do any operation for the 0 because we will ignore any empty cell, we don't need that. Now current minimum minutes is equal to let's initialize it to 0, and while the rotten queue is not empty, we will keep on traversing and making the neighboring fresh orange rotten as well. So the current coordinate of a rotten orange, what we will do is we will pop the rotten orange from this queue and check the neighboring orange. So the current coordinate of the rotten queue will be current row, current C, current column, and also the current minute is equal to rotten queue dot pop left. So we will pop the initial first rotten queue, get its row and column number, and also the current minute elapsed since the starting. Now for all the directions, right, left, up and down, so how can we write that? This will be the right direction. This cell means any cell next to the current cell horizontally on the right, and this will mean any cell below the current cell. This means any cell on left of the current cell, and this means any cell on top of the current cell. So for all these directions, we will append it to current coordinates, so that we can check the new coordinates if they are fresh or rotten. So new coordinate will be equal to current r plus dir 0. So this is the x coordinate on the row number that we want to traverse to. So initial row number plus dir 0, and for column it will be current column plus dir 1. Now we have the new coordinates. We have to first check if they are out of bounds or in bounds. So for that, while nr is greater than or equal to 0 or less than len grid, and it should also be in bounds vertically. So while nc new column is greater than or equal to 0 and less than len grid 0. And also we will check if the grid nr nc is equal to 1. So if it is a fresh orange, we will make it rotten, because its neighboring orange was a rotten orange, so we'll make it rotten. How can we do that? We can write grid nr nc is equal to 2, and also fresh orange minus equal to 1. And also we will append this newly rotten orange to the queue as well. So we'll add rotten orange dot append. So the new coordinates are nr comma nc, and also the minutes elapsed will be current minute plus 1. Now when we are done with this while loop, we will have gone through all the rotten orange and made all the neighboring fresh orange rotten as well. So at the end, after this loop, what we can do is we can check if fresh orange is greater than 0, then we can return -1, that we were not able to make all the orange rotten. Otherwise, what we can do is we can return the current minimum time that we that elapsed since the beginning. Let's try it out. Rotten orange is not defined, so probably a spelling mistake. So it is rotten q over here as well. Let's try it out again. Wrong answer, -1. Let's see what happened wrong. So we initialized a fresh orange, we initialized a rotten q as well, and we went through this grid to check. So for in range line grid, yeah, this is correct, this looks correct. We check if it's a fresh orange and append it to fresh orange. We check if it's a rotten orange, we append it to rotten q. Current minimum is equal to 0, and while rotten q, what we try to do is, so this is rotten q, yeah. So while rotten q, what we try to do is we can pop the rotten q, and we get the row number, column number, current minimum, and also for dir in 1, 0, which is the cell on the right, oh yeah, so it's cell on the right, it needs to be 0, 1, the cell below the current cell. This is the cell on left, this is cell on top. Let's try it out first. Maybe this was the mistake we made. Yeah, thank you for watching this video. Please consider subscribing to my channel.